This is Module 3, Lecture Notes 5. Before we get started on this set of lecture notes, I would like you to take a second to gather the materials that you will need. You will need your printed copy of the notes. You will also need a blank periodic table that looks like this, and a black marker, and 3 different colors of pencils or crayons. If you don't have those things handy right now, go ahead and press pause, go grab them, and then come back and we will use them. In this set of lecture notes, we're going to be talking about elements on the periodic table. And many times when you think of chemistry, you think of the periodic table because it contains the list of all the elements that have ever been discovered. Right now there are 118 of them. If you look at your table, you can see that it starts at element number 1 and it kind of zigzags down like you would read a book, and element 118 is right here. New elements are discovered every year, and it's kind of cool to look up their names and how some of these most recent elements that have been discovered have been named. What I think is really cool about the periodic table is that every single thing in nature can be broken down into one of these elements. Okay, think about the air you're breathing into your lungs. It contains a lot of hydrogen. It has some nitrogen, definitely some oxygen in it. Let's see, maybe the table that you're sitting at your desk or at your kitchen table, it can be broken down into its elements too. Maybe it's made out of wood, which has a lot of carbon in it. Maybe it's a plastic table, which contains some silicon. Maybe you're wearing a bracelet today, and it's made out of gold, or it's made out of silver. Here are some of your metals that we're very familiar with. If you look through this list of elements, I'm sure you will see many common substances that you are used to seeing on an everyday basis. And you already know many of them because you took the time to memorize, I think, 36 of them for this class, so that will come in handy. When you look at a periodic table, you need to know what these numbers mean. Okay, so we're going to define that in this square here. Let's do the element calcium. Okay, if I were to copy that square, it would have a 20 in the upper left-hand corner. It's going to have a big Ca in the middle, and it would have 40.1 down towards the bottom. So we need to know what each of those things mean. Ca, or calcium, is just the element symbol. It will always have a capital letter first and a lowercase letter second. Not all of them have 2 letters, but for the ones that do, that's how it should look. The top number is the atomic number. Okay, and the periodic table is organized by atomic number. Element 1 is at the top, the higher elements are at the bottom. And this 40.1 represents the atomic mass. Okay, so this is the weight or the mass of the element in atomic mass units. And those also increase as you go throughout the periodic table. Okay, now we're going to take some time to look at the 3 different classes of elements. The periodic table can be broken into metals, nonmetals, and something called metalloids. So you're going to take your 3 colors and just pick one for each of your classes. So this is what I'm going to go with. Now you're going to take your periodic table, and I'm going to show you how to divide the periodic table between metals on one side and nonmetals on the other. You're going to take your dark colored marker and you're going to draw a line to the left of boron. This line is going to zigzag down all the way to the bottom of your periodic table. Kind of like a stair step. Okay, and this dividing line is going to help us divide the periodic table between the two classes. Okay, I think the easiest one to color first are going to be the metalloids. The metalloids are going to be anything that touches this zigzag line except aluminum, because we know aluminum's a metal. So I'd like you to take a second and color in neatly, because you're going to be using this periodic table quite a bit, every element that touches the zigzag line. Okay, so here's what you should have for your metalloids, and we'll talk about what metalloids are in just a second. Next, we're going to do our non-metals, because there's not very many of them. So that's my aqua color. That's going to be everything on the right side of the periodic table. And if you look at some of these elements like nitrogen, oxygen, fluorine, chlorine, many of these are gases. Helium that we fill with balloons, neon. These are gases, and these are non-metals. Okay, these are going to be your second color. So take a second to fill all of these in. So here's what you should have on the right side of your periodic table. Now, of course, you're going to learn that there's lots of exceptions in chemistry. One exception to the rule is that hydrogen, even though it's on the left side with all these metals, it is technically a non-metal. Hydrogen is a gas. It is a non-metal, so it should be the same color as your other non-metals. So don't forget that one up here in the top left-hand corner. Now, everything else on the periodic table is a metal. You can see that that makes up the majority of the periodic table. So I'd like you to take a second to fill in the rest of the elements with your third color. All right, so here's what my periodic table looks like when it's finished with my three colors. Let's take a second to fill in this little key at the top. My metals, I used orange, maybe you used a different color. My non-metals, I used teal. And my metalloids, I used pink. Okay, so I just wrote metalloids in there. So that should help you with the colors on your periodic table. Okay, we can go back here to our key and just note that metals, we said, are on the left side of the periodic table. Our non-metals are on the right side. And our metalloids, I'm just going to write, they're the ones that are near the zigzag line. So hopefully that helps you jog your memory when you're studying these. And remember, hydrogen is a non-metal. Okay, so let's talk about some of these properties. Metals are something we're all pretty familiar with. Metals are malleable, and the word malleable means, can it be bent easily? Look at this piece of aluminum foil. Okay, it can be pounded into a thin sheet. It can be molded into a different shape. A paper clip is a good example. It can bend without breaking. This key ring. That's why a lot of jewelry is made out of metals, because it can be hammered thin and changed into different shapes really easily. Metals are also very pretty because they're shiny, and that is called luster, when it has luster. And metals are good conductors of electricity. You would not want to stick a metal into an outlet because it's going to conduct electricity. That's probably something you've been taught from a very early age. Non-metals are the exact opposite of these. Instead of being malleable, they're brittle. If you take a piece of plastic and you bend it, it's going to snap. It's not going to bend, it's going to break. It's brittle. They're often not very shiny, and they do not conduct electricity. Okay, so just think opposites on these. Metalloids sometimes have properties of metals and sometimes have properties of nonmetals. And that would make sense because they fall on this line where they're very close to being one or the other, so they're going to have properties of both. Silicon is a good example of a non-metal or a metalloid. Okay, silicon is shiny like a metal, but it's also very brittle. So it has a property of each. Okay, let's jump down here to this bottom section. We're going to talk about what happens when you put two different elements together. Okay, this is called a compound, two or more elements combined. That's called a compound. And there's two different types that we need to know for this class. An ionic compound is when you put a metal with a nonmetal. When you have one of each. That's called ionic. So that means you would need an element from the metals and an element from the nonmetals to join together in order to make a compound. A covalent compound is non-metals only, or a metalloid, but you definitely do not have a metal in a covalent compound. Non-metals, metalloids only. So you're going to be picking just from right here when you form covalent compounds. Okay, so one thing you should be able to do in this unit is to decide, is this ionic or covalent? If I take calcium and bond it to bromine and make calcium bromide, would I call that ionic or covalent? And it's really easy to tell just by looking at where these elements are in the periodic table. Calcium is in the metal group. Bromine is in the non-metal group. I have one from each side. It's ionic. I have a metal and a non-metal. Metal, non-metal. We call it ionic. Okay? I'd like you to take a second and pause this video and try to work through the last three examples. Name it either ionic or covalent. In this example, I have phosphorus and fluorine. Phosphorus and fluorine are both the same color, meaning they're both non-metals. When I have only non-metals, this is covalent. Sodium chloride. Sodium is a metal. Chlorine is a non-metal. I have one of each. What should I call it? Ionic. And then for the last example, I threw this one in there because I want you to remember about our exception with hydrogen. Hydrogen and oxygen are both non-metals, so this would be covalent. Okay, so hopefully that helps you see how you determine what type of compound depending on how your elements are classified. Ionic and covalent compounds react very differently when they dissolve in water, and they have very different properties. Ionic compounds dissolve really easily in water. Think about sodium chloride. That's salt. That's like salt you put on your food, table salt. We know that if you mix salt with water, it's going to dissolve really easily. It's an ionic compound. Ionic compounds also conduct electricity when they're mixed with water. Covalent compounds are the opposite. They don't dissolve as easily. They'll often dissolve, but it takes a lot more work to get a covalent compound to dissolve with water, and they do not conduct electricity. Okay, so these are opposites. You will be doing a lab at some point in this unit that will help you see the difference in these two properties. And it's kind of interesting to get a chance to dissolve some everyday compounds that you're used to things that we cook with and such, and to see how they react differently from each other. Thanks for listening.